Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session on emoji prediction using text sentiments. So without any further delay, let me quickly walk you through today's agenda. We'll start this session by understanding the problem statement and then the workflow that goes along with it. Moving ahead, I'll be walking you through the tools and frameworks that I'll be using, and finally I'll end this session by walking you through a hands-on demo. Guys, before we start, please do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking for online training certification in deep learning, please check out the link given in the description box below. So let us now quickly move ahead and understand what we are trying to do over here. So you see, in this emoji prediction project, we'll be working with the textual data. Each text here will be mapped with a particular sentiment. We all know that the texts are sequential data, and to work with the sequential data, we'll be making use of RNN and LSTM neural networks. If you're wondering why we are using RNN or LSTM neural networks, that's because the preceding data is totally dependent upon the old data. And also, if you're someone who's totally new to RNN and working with deep learning architectures, I would strongly consider you to check out our deep learning playlist, the link for which will be provided in the description box below. Coming back to the agenda, we'll be creating a model based on the textual data set. And the final outcome of this project is that we would be able to predict the sentiment of any given input statement. So what are the prerequisites that you would be required over here? Obviously, as I mentioned earlier, you would definitely have to know Python and also how you work along with deep learning. And apart from that, you should know how to work with various frameworks such as Keras, NumPy, sklearn, and many others. So what is the workflow of this particular project? So now you would be wondering how we are going to work with this. Like, what is the pipeline of this particular project? You see, first off, we are going to collect our data and then load that. After that, as is a textual data, we have to pass this to pre-processing. Some of the stages that involves over here are removing of the stop words, limitization, tokenization, and many others. Once we're done with pre-processing our textual data, we are going to create embedding matrix out of it. In order to work with this embedding matrix, we'll be working with pre-trained model like 𝐿STM or word-to-vec models and many others. Finally, once we have our embedded matrix, we're going to feed this to our LSTM model, and then we are going to train a model. And finally, we are going to validate if our model is able to predict whatever is the expected outcome or not. So let me now move ahead and quickly give you a glance through of what are the various tools and frameworks that we'll be using here. So see, for me to write a code over here, I'll be making use of Google Colab. Google Colab, if you don't know, it's basically a Jupyter notebook and it provides me a free GPU to train my models. Apart from that, couple of basic frameworks that I'll be using here are NumPy, Matplotlib, and sklearn. To work with our deep learning models, I will be using Keras framework, which is basically a backend of a TensorFlow. So now that you know what we are going to work over here with, let me now quickly jump to my code editor and show you how we can build our own emoji prediction system. So as you can see here, I have come down to my Google Colab. For me, the data set that I'm going to use, I have already loaded my data set over here. So we have train-emoji.csv and test-emoji.csv. And this is basically our embedding model. This is the pre-trained model. So before we move ahead, let me just quickly give you a walkthrough of our data set here. So to read our data set, what I'm going to do, I'm going to use a model over here. That is, it's going to be import pandas as PD. Let's also import NumPy as an PRA. And yeah, I think this should be sufficient. And let's now read our train data, right? So let's give here as train. And this would be PD dot. We have this function called as read CSV. And here I'm going to pass the file path. And we'll give here as train.head. So as you can see here, we have a statement here, and this 2 here represents the emoji code. I'm going to come back to this part here. So let me now quickly execute this block of code. So as you can see here, we have our data frame. And if you can see, right, we have a small issue here. The first row, like the row which is responsible for telling me the feature name, have taken this part here. So this is wrong. So we are going to fix that up by, let's say, columns. Instead of columns, we can just do here as header. This would be none. Okay, that means we don't have anything on top. And if I execute this now, you can see it shows me 0, 1, 2, and 3. Now, as you can see here, we have a lot of data missing here. We are going to drop column 2 and 3. But the column 1 over here represents which emoji this thing belongs to. We are going to come back to this in a while. But meanwhile, you can see the data set here. So never talk to me again is represented by this code 3. And we are going to map this 3 to a particular emoji. And let me now also get our test data. So test is equal to, this is going to be the same, pd.readCSV. It's going to be here. And then we are going to take the test, copy the path here and add it. And similar to before, we are going to add header. This will be none. And let's see test.head. So as you can see here, these are the expected outputs here. And yeah, so now what we're going to do now is try to remove these two columns. So it's pretty simple to do that. So it will be train.drop because this is a data frame now. And now this has this column here called as labels. And here we are going to pass 2 and then column number 3. This is going to be string. And then finally, let's see what happens now. We're supposed to pass an axis. So let me quickly get that done as well. This will be 1. Looks like this is an integer now. But as you can see, we have not dropped this. The reason is because we have not updated the train. So either you can write train over here, or you can also have an argument passed that is called as in place. This should be true. And now you can see the column 2 and 3 would have been dropped. Looks great. So now we have a proper data set to work with. So let me give a comment before we move ahead. Load the data set. So now let's move ahead and understand what does this code over here represent. So I'll give here as emoji. In Python, we have this module which you're supposed to install. So it's called as pip install emoji. What this emoji package over here does is that it gives me all the emojis that are available here. So if you don't believe me, let me quickly show you that. So import emoji, and now let's say I want an emoji from English letter. Let's say something like emoji dot emoji Unicode English. I can just pass here as en, and let's see what are the various emojis I would get. So I've done this small typo. Let me fix that up. So as you can see here, these are all the emojis that we have. We have this thing in different languages as well. If you can see here, if I try to remove this and add some column. So we have in Espanol, and then we have PT and whatever the other it represents. So now as we are dealing with English, so we'll add English here, execute this. So now you can see here, right? For every emoji, we have a particular Unicode value here. And similarly, if I scroll up a bit, you can see that, let's say for drink, clicking 2 glasses, then here clapping hands, light skin tone. We have various ones. We have butterfly. And now you might be wondering, what exactly is this? So how do I get this value? Well, to get this value, let me execute this once again. So if you have to understand how do I get this, all we need to do is, this is basically a dictionary, and we just have to pass this value here, books value. And I'm going to show you how do you do that. Just give me a second here. So as you can see, this is basically a dictionary at the end of the day. And if you are someone who wants to make use of this, like first place medal. So what I'm going to do, all I'm going to do is come here, just type emoji. And then we have this function here called as emojize. So emojize, EMOJIZE. And now all you need to do is pass a particular value here, pass a string value. So let's say that I need this string value. So I'll copy this and pass it down over here. So now you can see, right, now I'm getting this particular image. Similarly, if I take down any image over here, like let's say this Aries one, and if I scroll down here and add this Aries, so the emoji over here changes to this particular Aries emoji here. So now what we are going to do, we know that we can map our emoji, and we are going to map this to a particular sentiment, and we are going to have a dictionary. That dictionary is this value. So 3 here is something like sweet face, and 2 can over here represent I'm proud of your achievements. So this can be something like smiling face, and 0 here miss you so much. This can be something like a sad face or something. So let's first create a dictionary here. So let me erase this. Let me run this once again. And meanwhile, let's also create a dictionary here. So emoji underscore dictionary. And if you know how you work with dictionary, first off, we'll give here as 0. And this would represent some value. Then we have 1. This would represent a particular value. And then we'll have 2. This would again represent another value. Finally 3. And then 4. So what does this thing represent here? Or what do we map this to? Let's quickly see that. First thing that I'm going to map over here. Now we are going to see this 0 here. She got me a present. So I think she got me a present is something that would look like a happy face, something that you want to express your happy feelings towards it. So let me quickly get that done. Let's see where I can find a happy face here. So as you can see here, now we have come down to the emoji faces. So what we're going to do here is we're going to take an emoji that represents some love or affection, or something like a heart or something. We can also take, let's say, something like this. I think this looks great. Face with a tongue out. So let me copy this, and I'm going to map this over here for 0. So this basically represents, happiness. And then let's see, what should we map 1 to? We have somewhere 1. So 1, I can map this to something like a ball. I will map this for a ball. Let me quickly search a keyword for that. Let me scroll that somewhere up. And yes, I found a ball. I can add either this or this, totally up to you. Let me take this ball here, baseball, and scroll down a bit. Don't forget to give a comma over here. Then finally coming down to 2. 2, we want it to be something like a happy face. Something, a face that represents overexcitement or something. So let's search that stuff. So we have this. So I'll map this to this part here. Face with tears of joy. The fourth one would be a sad face. So let's take a sad face over here. We can take this as a sad face. So we want an image where represents a sadness. What I would say is you can add any emoji that you want. It's totally up to you. And finally, let's take something which represents food or something that you want to eat. So let me take out bread over here, as bread represents a food, something that we want to eat. And I'll add this over here. So now we have created our emoji. So now in order to cross verify whether everything is working fine or not, or if you have done any mistakes, let's create a for loop. So for e in emoji dictionary dot values. So basically this would give me this. And what we are going to do over here is just print out emoji dot emojize that particular emoji. Okay, that is e. And I don't want this to go on the next line. So I'll just put here as end is equal to so and so. So as you can see here, this first one represents something over love. And then you have a baseball. That means you have some text that represents something that you're trying to play. And then we have a smiley emoji here. And then we have someone being sad and the food. Let's try to change this. Let's put something else here. I think this would suit over here better. With this, I can distinguish between this emoji and the other one. So this looks great. Fine. Now we have the emoji, we have the dictionary of the emoji, and as you can see, right, we have mapped zeros over here to the zeros over here as well. So now on our next stage, what we're going to do is we're going to pre-process our text. So let's see what we can do to pre-process our text. So first off, let me just write a text over here. Let's say pre-processing. So first thing what I'm going to do in our text pre-processing is get this value. So I'll get these values in zeros and one. So let me quickly get that done. So I'll have x train. This would be equal to train. And in this, I'm going to pass text. As we have not given the values here, it will be just zeros. So it will be 0. And then we are going to pass here as values. And let's now see how does this look like. So x train. So as you can see, this is basically an array. And similarly, I'm going to do this for y train. Y train. This would be train of 0, or this would be 1 dot values. So if you want to see what does this represent, x train, as I've showed you earlier, let me quickly show it to you here again. I just need top 5 sentences. So as you can see, I have never talked to me again. I'm proud of your achievements. These are basically sentiments of the people. And now similarly, if I put something like, let's give 10 here. And similarly, let me do the same for y. So as you can see, we have a mappings here, like never talk to me again. It represents to 3. And 3 here basically means something with angry face. So face with a headed bandage, something that represents sorrow. And similarly, food is life. So this is something like 1, 0, 1, 2, 3, and 4. So 0, 1, 2, 3, and 4, which is the 4th index. And here we have something that represents food. So this is how the texts have been mapped. And now what we'll do is, let's see the shape as well of our x train and y train. So as you can see, we have same number of rows over here, and it's a pretty fairly small data set. And this is perfect for someone who is trying to start off with working with RNNs. So now that we are done segmenting our data, like classifying them between train and test and what is a dependent feature and independent feature, now let's try to create an embedding function. If you remember well, and if you remember how RNN works, we have to obviously embed our data. We just can't pass this directly to our RNN model. So we have embedding layer. So there are 2 ways to do it. Either we can create our own embedding layer, or the second type is we can use pre-trained models. And the pre-trained model that I'm going to use over here is going to be glove. So we are going to create a function here. Let's give a comment here, get embeddings. Let me put this as a textual comment so that it's easier for you people to understand. Let me tell you this thing comes under text pre-processing. So for this we have, as I mentioned earlier, I'll be using glove vector. So for that, so let me have f is equal to open. I have to read my data. Let me copy the path here, copy path, and then pass encoding UTF. This is pretty important if you're someone who is working with Microsoft. I have to put encoding values. And let me execute this up. Now I'm going to create a dictionary here, an embedding matrix. This is going to be a dictionary. So let's now create a for loop for line in F. If you want to see what is F, let me execute this. So this, as you can see here, this is the content of this part. So let me give this one over here as well. So mode by default is read, right? So we don't have to give mode. If you still want, I can just write here as R, read. So let's now see what is present in F. So you can just put here F dot read, and you can see all the lines over here. This should take some time. The reason is because we have 6 billion lines of data, which is a pretty huge file. So as you can see here, we have the vectors for every word. If this is D, we have vectors for this. Now let me quickly show you what we can do here for every word. So for line in F, then here we'll give values, that is line dot split, and then word is equal to values of 0. You'll understand this, what I mean. 0 over here represents a word in the beginning. So as you saw D, right, that's a word. And then we'll capture the embedding here as well, EMB. This will be equal to np.array. And here all I'm going to do is values from the first index, because the 0th index is the word. And here the data type would be float. So now we'll add this to our embedding matrix. So for that particular word, what would be the embedding? So EMB. It looks good. So let me execute this. And now you might be wondering what happened here. So if you remember, embedding matrix is just a dictionary. All I'm trying to do here is for whatever word I have, like for D, we'll have certain set of embedding. So I'm just going to map it to that word. So if I show you here embedding and execute this, we are not getting anything. So let me quickly get that done again. So let's first see what we are getting here. Print values. So let's try rerunning this over here, and then we'll also run this again. And now let's see what does this embedding matrix have for us. So as you can see here, for every question, I have an embedding matrix present over here. So each of these values are unique to this word. Similarly, each of these values over here, forward, each of these values represents the word forward. And the size of this is going to be 1 cross 50. So that's what is the embedding matrix size over here. So if you want to see the matrix size, so all I'm going to do is embedding matrix dot values. We'll take the one value dot shape. So this is a dictionary. So what we'll do here, let's take some value here, and then we'll take shape. And if I execute this, so as you can see here, we have 50 rows that represents this one particular word, this. Now if I try to use some other word, you'll see that the embedding matrix would remain the same. Like let's say D. The size over here represents the same stuff. So now what we're going to do here is whatever the textual value that we have, so whatever values I have in my text pre-processing, or test pre-processing, or even text train pre-processing and all that. So I'm going to create a function. This function is responsible for whatever sentence you put, it's going to create an embedding matrix for that. So for that, I'm going to do def get embedding matrix for the data. For data, you can give the name of whatever you want, and I'm going to pass here data. Data here represents a word. So then we are going to fix a maximum length. So max length, let's say it's going to be 10. And now what we'll do is we'll just create embedding data. This thing will be np.zeros, and the shape of this is going to be 50. So let's say length of the data, comma max length, and then 50. Why am I taking 50? Because each word over here represents 50. If you remember, each word present in this dictionary is of size 50. Let me add one more bracket over here, and yeah, this looks great. So now what we'll do for ix in range data.shape. What does this data over here represents? Data over here represents the sentence that I'm passing. So data.shape of 0. So if embedding matrix dot get words in sentence ij dot lower. Okay, before that we have to do something else. So this here basically you're trying to get into the each word of the sentence that we have. And now we are going to create variable here. Let's say words in sentence. This should be data ix dot split. And now we are going to have a for loop which goes through the sentences for ij in range length of words in sentence. And now if embedding matrix dot get, that is if that particular value is in there, if this is a new word, so word in sentence, I'll give an index here as ij dot lower is not none. If this is the scenario, then we are going to add this to a new value. So embedding embedding data. That is, we are going to add this. So embedding data of ix and ij is equal to embedding matrix, then words in sentence. We'll pass the index value ij dot lower. And what this would return? This would return embedded data. So this says invalid syntax. Let's see where we are going wrong. So let me execute this. I had done some small indentation error. I had not closed this parenthesis. So now we are done with this particular part. So now you might be wondering, so what are we trying to pass over here? Well, let me give you a quick walkthrough of this. Over here, I'm going to pass a data. This data can be complete xtrain or xtest, no matter what it is. So it will go through each row. This is where it goes through each row, and then each row will have a couple of sentences. So this is what we are trying to split. And then whenever I use a split sentence, this would create an array. And we are going to iterate through every array. And if that particular array is not present, if that particular word is not present in this particular data set, then we are trying to create a word embedding for that, and that would be 0. So this is what this thing represents. So now if I put here xtrain, and then I'll have get embedding matrix for data, all I'm going to pass here is xtrain. And now if I try to execute this, and if I show you what does this xtrain represent, you will see this will be numbers now. Each number over here is basically a word. So each of these represents a word. And wherever we see only zeros, it means that that particular word was not present in our glove model. Similarly, we are going to do this for the train, and we'll look into the train later. So now let's see what is the shape of this xtrain.shape. As you can see, we have 50 dimensions. 132 is the number of rows that I have. So 10 over here basically represents the max length. So if the number of words in a sentence is more than 10, that word is particularly chopped off. And now let's do something. Let's try to convert whatever values we have to categorical. So what are the categorical values? They are the output variables. So these are the categorical variables. And let me show you what's going to happen once we do that. So convert the output to categorical. So for this, I'll use from keras.utils import to categorical. Make sure you put this np.mputils, or else you won't get this to categorical values for here. So now I have this for a white train, and we'll just say to categorical, and we're going to pass white train values here. And now if I show you what this would look like, white train. So as you can see here, now we have 4 classes. So this has just converted into one hot vectors. So by any chance, if you don't want to use this to categorical, all you need to do is change the loss function. You can just change the loss function from categorical cross entropy to sparse categorical cross entropy. So now that we have got our data set, now it's time to build our model. So over here, I'm going to use from keras.models import sequential, and apart from that, I have so it's going to be from keras.layers import LSTM. Then we have simple RNN. Then we'll also have dense. Dense basically we use for classification at the last stage, and then we'll have dropout. We use dropout, if you know, it's for preventing overfitting condition. And now we'll build our model. So first off, I'll give you a model is equal to sequential, and let me execute this so that it's easier for me to add. Then it will be model.add. So I'm supposed to add LSTM unit here. So it's going to be LSTM, and number of units or number of neurons that I want over here is going to be 64. The input shape, if you remember, input shape is going to be 10, 50. That is 10 over here represents the maximum length, and 50 is the dimensions. And then apart from that, I have written sequence. This will be true. Now to prevent overfitting, I'll just add here model.dropout, and I want to drop out 30% of my existing values. Again, I'm going to use model.add LSTM, and then we'll have units. I'm going to decrease this. Now instead of 64, it will be 32. And again, I'll use a dropout. And finally, now that we are done with this, all we'll do is add dense layer, model.add, and here we are going to add dense, and number of units I'm going to give here as 10, and then activation will be relu. And for the final layer, it will be model.add and dense, and units over here would be 5, and activation will be softmax. So now you might be wondering, why have I used 64 and then 32? Well, you see, when I'm working with LSTM, and now that we have a very little amount of data, I think it's only about 164. If I try to add more and more layers, there's a high chances that my model will overfit. So if you're wondering why have I used 5 here, I would give this as an assignment to you guys. And if you want the hint to this, it will be present at the end of this session. And if you know the answers for this, please do mention that in the comment box below. So let me now execute this and type model.summary. So as you can see here, we have 42,000 trainable parameters, which is less compared to what we usually do. And finally, this thing over here represents the batch size. This is the input shape, that is 10 words, and 64 is the dimensions over here. And the reason why we have 64 is because we are passing 64 neurons here. So this is all there is about creating a model. Now we'll try to compile this. So this will be model.compile. We'll pass here optimizer. The optimizer I'm using is Adam. And then we have losses. So for loss, I'm going to use categorical cross entropy. Let me import keras here. Execute this up. And here it's going to be keras.losses.categorical cross entropy. And finally pass a matrix. And I'm going to give here as accuracy. Looks great. And finally, all we need to do is train our model. So let me give this here as model training. So here we'll have history, HIS. This would be equal to model.fit. And then finally we'll have xtrain, ytrain. Ytrain over here, as you know, it's one hot vectors. Then we have validation split. Let's give it as 0.1% because we have a very small amount of data. Batch size, for every batch I'm going to give 32 images. And epochs, let's give 50. And let us now execute this and let's see what happens. As this is a language model, it usually takes a lot of time to train. So what I'm going to do is I'm going to quickly change this runtime type to GPU. So as you can see, we have started training a model. This is going to go on till 50 epochs. This will take quite some time, but as this is like a very small data set that we have, it won't take much time. Yeah, as you can see, right, we have successfully completed our model. And yeah, slightly our model is overfitting because over here we have accuracy as 100, but validation accuracy is just 64, but it's all right. The major reason for this is because we have a very small data set. So now what I'm going to do is, let's try to predict the values. Let's see if we are getting the correct values or not. So for that, we have something like model.evaluate. And now first off, we'll do it with xtrain, and then we'll also do it with ytrain. So as you can see, the accuracy that I'm getting now is 96. If I just put here as 1, so this is my accuracy, 96%. To give you a better understanding of what I'm doing here, let me multiply it by 100. So this is my model accuracy. And now let's try to do this with respect to the test value. To get the test values, we have a small click here. So as you can see from our data set, like if I scroll up somewhere here, we have, so this means that we have not imported our test values. So let's quickly get that done. So importing test values. So first off, what we're going to do is obviously read this CSV file. So we'll have something like test, and this would be equal to pd.readCSV. And we're going to pass this test value over here. And then we obviously don't want the columns. So if you don't want the column, then we have this particular keyword. If I show it to you over here, header. So as you can see, we have already imported the test data. So we don't have to do this again. And if you see here, we have this hash t. So /t. I don't want that. So if I have to remove this /t, I'm going to write a small lambda function. Let me show you that. So we'll change this as test data preprocessing. So as I have already written this. So we have this lambda function, and except for the last one, so except for the hash symbol, I don't want any of the values. So let's now see how this would look like. x_test. It's going to be test, and let's execute this. So as you can see, now we don't have that hash t. So now what we'll do is we'll try to evaluate how a model performs. So it will be model.evaluate. Let me tell you, this is the data. The test data is something which we have not done any alteration on. So we have x test and then y test. We just want the accuracy. I'll give here as 1, and we'll multiply that with 100 just so that it's easier for us to understand. The reason why we are getting this error is because we're supposed to pass this through our function. What is that function? If you're trying to ask, we are supposed to pass this through this function. Similarly, the way we have done it for our xtrain get embedding, we'll do this over here as well. So let me copy this. When it comes to deep learning models, right, it's pretty important that the input shape and input format is the same. So it's going to be x test, and we're going to pass here x test values. And then we have y test. If I'm not wrong, this is 2 categorical, and this would give me 1 hot vector. So y test. So now that this is done, let's now evaluate a model. And as you can see, we are getting 60%. This is fine as we have a very small amount of data set. It's totally fine. I mean, it's totally fine to get 60% accuracy. So now what we'll do, I'll write a function over here. let's say 𝑦Pred. Let's see what percentage of our data we are getting it false. So 𝑦Pred is equal to model.predict, and I'm going to pass here as xtest. And now we'll just write function here. Let's say something like for t in range, and we'll have length of test. So we have to print the test. So print test, and this will be nothing but a text.ilog, and this will be ilog of t. T over here represents the index. So let me change this from R to T. So now let's see what does our model predict. So print predictions, and this would be emoji.emojize, and now this basically is going to give me emoji dictionary. Then we'll have to convert this into a string 𝑦Pred of t. And similarly, we'll do this for the actual value. Print actual. We missed a comma here, and let's fix this up. Emoji.emojize. It will be similar, except for predict, it is just going to be test value. Let me copy this and paste it over here. So it looks like there is going to be a small change. We have this fine. We have this dictionary, which is totally fine. This is that instead of 𝑦Pred, it's going to be test. So in the text, we have this in the column 1. And then we have to just put ilog of t. That's the index. And now finally, we'll just have print and give this. It looks like I've done a small typo here. Yeah, so instead of test, it's going to be 0 over here, because that's the name of the column that we have given. So the reason why we are getting an error over here is because we are passing this entire array. So instead of this, what I'm going to do here, instead of predict, I'll just use predict classes. So we have this new function called as predict classes, and this will just return me the classes, right, instead of an array. And now if I show you what this thing represents, 𝑦Pred, as you can see, it's just the classes. And let me execute this now. Let's try to validate how well our value has worked, our model has worked. So as you can see, she got me a present. The prediction was this, but actual was a heart one. Ha ha ha, it is a funny one. So the prediction is the funny emoji, and this was fine. Yes, sometimes we can see here there's a correlation, actual and prediction. The happy and the heart, like overexcited one, usually they have the same words. But this one over here, which clearly makes a distinction, like food, it has represented properly. The ball, yes, this has worked. So in almost all the cases, the model is working fine. The only place where the model is performing really bad is the one where there is a similar type of emotions. So this is where our model is trying to perform bad. Alright guys, this is all there is about predicting the emoji based on the sentiment of our sequence. So now you might be wondering, what can you do more further to enhance your project? Well, you can create an automated keyboard where any text you write, like you say happy, and you get the emoji of a happy face. When you put a love, you get a heart symbol. So this is how you can enhance it. And the way you can do this is by using Pygame library. When you're trying to use that continuously running loop, you can make use of that as real-time working projects. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!